Kia ora koutou, welcome to this next video for Science 1.1 Mechanics. Today we're going to be looking at acceleration. So acceleration is the rate at which something either speeds up or slows down, or the rate at which something changes speed. So if we had an object that was stationary, that is not changing its speed, so that object would not be exhibiting any acceleration. Likewise, if we had an object that was traveling really fast, so if we were in a car that was traveling 100 kilometers an hour down the highway and it was staying at 100 kilometers an hour, there would be no acceleration on that object either. So acceleration only applies to an object that is changing its speed. The units that we use for acceleration, the symbol is a lowercase a. The units are what we call meters per second per second. So you can see that written either like this, m divided by s squared, or you will see it written like this, ms power of negative 2. So meters per second, what that means is per second, how many meters per second is the object increasing its speed or slowing its speed. So if something was accelerating at 1 meter per second, that would mean that every second the object would increase its speed by 1 meter per second. So it's something that you just need to get used to. Meters per second can be written as m divided by s squared, or ms to the power of negative 2. To find out the acceleration of an object, we use the formula a equals acceleration equals the change in speed. So remember, speed, we use the symbol v to indicate speed. So v stands for velocity. In this course, we use velocity and speed interchangeably. So we've got a equals change in v, that's lowercase v, divided by the change in time. So that is the change in how fast something is going divided by how long it takes for that change to occur. So if an object was to change speed by, let's say, 1 meter per second, if that happened over a really long period of time, this number would be really large. So you would end up with a small acceleration. Whereas if this was 1 meter per second, if the change in velocity was 1 meter per second, and that occurred in a very short period of time, let's say 0.1 seconds, then the acceleration would be much larger than it was for the previous value. So we'll just give an example, we'll work through an example of this. So let's say we had an object, or we'll say a car, changes speed from 0 meters per second to the power of 2, so that's 0 meters per second, to, let's say, 2 meters per second. Oh, sorry, no, because we're talking about speed, all we need is meters per second, to 2 meters per second. This is a very, very common mistake, and one that I sometimes forget to do, is the difference between the units for speed and acceleration. So the units for speed, remember, are meters per second. The units for acceleration are meters per second. So it depends on whether you have this number as a 2 or this number as a 1. Okay, so you would be marked down if you got that wrong in an exam. So a car changes speed from 0 meters per second to 2 meters per second in 4 seconds. Calculate the acceleration of the car. Okay, so we will just need to plug in these values into our formula. So we've got acceleration equals the change in velocity. So the change in velocity, or the change in speed, is 2 minus 1. So it's the final speed minus the initial speed. So overall, we've got a change in speed of 2 meters per second. So acceleration is 2 divided by 4. So it takes 4 seconds for the car to change speed. So 2 divided by 4, we'll end up with 0.5 meters per second, like that. So what's important with this is that we are calculating, we're doing the change in sign. So in this case, it was easy because we were starting at 0 meters per second, and the time started at 0 as well. So we'll look at another example of how we would calculate the acceleration if a car was starting already moving and we needed to calculate the change in speed. So we'll just write up another example. So a car is traveling let's say it's traveling at 10 meters per second, and it slows to let's say 5 meters per second in how long should that take? Why not 2 seconds? Calculate the car's acceleration. So for this one, the acceleration is going to use the same formula. So A equals change in speed over change in time. In this case, the change in speed is the final minus the initial. So what we'll do, I'll calculate that over here. So the change in speed equals final speed minus the initial speed. So the final speed is 10. Oh, sorry. The final speed is 5 meters per second. So that it slows down at the end, it's going at 5 meters per second, and then at the start it is initial, it is 10 meters per second. So the change in velocity is going to be a negative value. 5 minus 10 equals negative 5. So the acceleration is going to be negative 5 divided by 2. So negative 5 divided by 2, you can put this into your calculator, should equal 2.5. So negative 2.5 meters per second to the power of negative 2. So in this case, the acceleration is a negative number, negative 2.5 meters per second because the car is slowing down. So every second, the car has reduced its speed by 2.5 meters per second. So that's basically acceleration. In the next video, we'll look at how to calculate acceleration from speed time graphs. Thanks for watching. Like and subscribe for more science videos. Thanks.